Excellent, thank you. I'm Justin Weibel in mechanical engineering. And so today I wanted to talk to you about a sensor that we've developed for detection of gas or other types of immiscible phases in fluid flows. And so specifically, right, what are we doing? What is the concept of our sensor here? So if we have some channel, we've got some liquid flowing through it, some gas flowing through it, and we actually have electrodes or some type of sensor that is measuring the impedance across those phases. We can actually detect something such as particulates or a gas phase with that sensor if the two materials have differing electrical properties. And so in this case, for example, gas and a water phase would have very different electrical conductivities, and so we can detect or get the quantity of gas in the channel itself. So that's what we're doing. So how do we apply this to microchannels? So conventionally, this type of approach is actually applied by actuating electrodes around kind of the circumference of the cross-section of the channel. It's very difficult to embed sensors if there's a large array of very small channels in that type of approach. What we've done is said, let's go ahead and put those sensors just on a cover plate that's going to mate against those channels themselves. And in this way, it's very easy to fabricate. However, there's a catch to this. The signal response when actuating the electrical field in the flow in this way changes the sensor response. So what we've done is we've kind of understood the calibration in that orientation and demonstrated that we can have some detection. So where would you use this? Right, microchannels, small-scale channels are used in numerous things. I'll just give you two that let you kind of think of your own applications. So an industrial example would be something like a microchannel evaporator or different heat exchange components. We'd actually be evaporating or creating vapor in a refrigeration system. Here, monitoring the amount of vapor can be critical for control of that system and the efficiency of that system or preventing failure conditions. More on the medical devices side, you might see something like hemodialysis, microchannel-based hemodialysis, where it's critical to detect any gas bubbles that might have air embolisms or other things. And it's not limited to detection of gases, even if it's oil droplets or other materials, anything that would actually have differing electrical properties in that flow. So what are the benefits? And I'll kind of contrast it just as a few alternatives. Of course, you don't need any optical access here, and you can embed this electrical sensor into your device directly. But you can get similar high resolution or high quality visualization of the flow as you would kind of if you saw it visually. You can do this with other types of ultrasound radiation-based approaches, but those are typically cannot be done for real-time detection at high speeds, or they're power-intensive, cost-intensive. And then alternatively, there's probe-based sensors, but then especially in medical devices, you actually need to insert these into it, so there's issues with contamination there. So what have we done? This is our test facility. I won't describe it. Basically, what we do is we have a device where we can control the amount of gas that's actually injected into a channel, as well as the electrical properties of those two phases in order to assess how our sensor actually responds to that situation and measuring it with this approach. And I've got a sample kind of in the other room. In terms of demonstrating this, this is my densest slide. I won't ask you to read all of these things quickly in a minute pitch here, but basically we're seeing visualizations of gas bubbles flowing through the channel. There's three things we can get from this data. We can detect whether or not there's the presence of a phase, the presence of a gas or other materials. We can get information about the quantity of that phase. And we can also get some of the morphological characteristics in terms of visualizing this, whether they're bubbles, the shape, the other thing that it might be, depending on the type of information you actually want.